Hi everyone. So today I'm going to start off with a little story. A couple of weeks ago, I learned about a new robotics pilot program happening in Vancouver. I was asked by a journalist to comment on this mobile delivery robot that would be introduced into the Vancouver downtown core and into this beautiful neighborhood of Kitsilano. Now, Vancouver has about 130,000 workers in technology, and I'd like to think we consider ourselves open to new technology and being especially progressive at the conference at Upper Bound. So I think many of us are optimistic about what technology can bring, but when I looked up as to how people were responding to the approval of this mobile robot project in Vancouver, these were the types of comments the robot was getting. 111 upvotes for the Vancouver sidewalks are already small and in terrible condition. Why do we have to share them with delivery robots now? And I can't wait to see elderly people and folks in wheelchairs having a standoff with these useless effing clankers. And so, although many of us here are optimistic about AI, we have to realize that there is a sense of derision with these robots. And here's the thing, I don't think it's a niche opinion. And I was trying to understand what's this underlying feeling under all of this. And one thing I think might be the problem as we think about people having face-offs with robots is in a face-off between a human and a robot, who is going to win? And if the robot, for whatever reason, technological or otherwise, is not ceding the way, who is dominant in that interaction? I think what people are worried about is that robots are having a leg up over humans in this hierarchy. And that means that who owns the streets? It would be the robots and not the humans. Now, if the robot turned out to be a very good citizen and had the technology to always, oh, I'm so sorry, and get out of the way and never cause anyone any discomfort, I think that would be something that they could use to prove, that this is something to be deployed. So for me, the real question is, could robots treat us like real humans? That is, humans that are supposed to be the ones in control. We're not just objects in the world to avoid, like a trash can. We're real humans. We have feelings, thoughts, intentions, emotions, and humanity. And I think what residents are worried about is that the introduction of robots might make us lose that agency control, and that people, the developers of technologies, are not taking into account that feeling. So in my lab, I really try to think about how we could develop robots that adapt to us as humans and not force us to adapt to it. My lab is called the Robots with Social Intelligence and Empathy Lab, the ROSI Lab at Simon Fraser University. And what I think about is how robots could be compassionate, understanding, and put humans first. But when I was asked again by this journalist, well, why is it so hard? Is it more difficult than having humans be, for example, targets for robots? And it's true. One of the hardest parts about this is somehow we need to be able for robots to understand humans as these interaction partners who can also be unpredictable, varied, right? So many different paths of interaction, and trying to understand what people also feel in this interaction is extremely hard. Some of the other difficulties is when we try to deploy these robots or technologies into the wild. At every moment, the people and their interactions are changing, and also the context changes. I come from a background where about 10 years ago, I worked at this company called SoftBank Robotics, and we built this robot called Pepper, the first mass-produced humanoid robot in the world. And we deployed copies all over, in homes in Japan, in car dealerships, in train stations, in elderly care centers, in shopping malls. And, to be honest, this was just a robot that stayed in the same spot. But it had to deal with all these different types of people and different roles. So today I'm going to talk about 3 different challenges that we need to address if we want robots to be more compassionate machines. And for many years, people have been trying to develop this idea of socially intelligent robots. And one of the first questions that people think about is, um, if robots are supposed to be empathetic to us, could they ever really understand how we feel? This was one of the first things I tried to tackle when I was working on the Pepper robot. This was a demo at CES in around 2016. When it detected I was sad, Pepper slumped over and sunk its head to the side, but a smile made Pepper cheery and wave its arms around. It was oddly comforting to see a robot try to empathize with your feelings. Now, this was back before the big language model era. It was just using standard facial expression detectors and reacting to them. But the problem was this. In a demo, this seemed to work fine. It would react to smiles and frowns. But in reality, people express themselves in so many different ways. And you can imagine trying to develop this in Paris, France, where the R&D headquarters were, and then deploying it in Japan. You can imagine how that went. And generally, this idea that you can detect how someone feels from their external behavior, maybe there is some signal there, but there's no way to be sure that there is a one-to-one mapping. I can't ever be sure about how someone feels just from the way that they express themselves. And so after several years of trying to make this work, I decided to go back to academia to try and understand this better. There was something we were missing. And indeed, a few years later in 2020, articles started to come out about how AI, quote unquote, emotion recognition couldn't be trusted. And I completely understood what they were talking about. There was even a 70-page paper put out by psychologists in the field working with computer scientists saying you just can't do that. And it became such a clear-cut problem that the EU AI Act banned emotion recognition in the workplace and in educational institutions. You can't use biometrics to do that because they simply are not reliable, and the underlying premise may be flawed. As an example, on the left, you can try and think about what this person is feeling. A scrunched up frown, mouth wide open, yelling. You might think that this person is having a really bad time, but in fact, they had just won their game. On the right, we have this jaw drop, wide open eyes. You might think that this person is reacting in surprise to something, but they were just talking. For a very long time, and this was a paper published in 2008, psychologists have known that context has a great modulatory effect on what is perceived by people, and this theory of mind that we have. The same face on different bodies can produce different things. They could be perceived as anger, as fear, as disgust, or even sadness. Same face, different context changes everything. And that's kind of the underlying problem of trying to think that facial expressions alone could help us understand how someone feels. And so one of the things that we were trying to do recently is benchmark vision language models, VLMs, and ask if they were given the whole context, could they perform what we'd call contextual emotional theory of mind. And here, if we're trying to infer how the person on the left is feeling, you could take into account the whole context of what is happening, the person pushing on their chair and imagining how they would feel in that situation. Now, we're not per se saying that we could understand how this person is feeling, but if we were to collect a whole bunch of annotations of people that perceive this, how well do VLMs model or reproduce that apparent emotion? And we call this apparent emotion recognition. But it's still a very difficult problem. And another reason why this is still not a super valid approach is because even in this model, the emotic data set, which had all these different pictures of emotions and context, had a whole bunch of people trying to annotate the same picture. And the results were all over the place. People saw different things. This is not a task like detecting whether something is a dog or a cat or a chair. It's not an objective task. Many times it's subjective. And it seems so obvious that an emotion is subjective, but in machine learning, we've been trying to treat it like it's an objective task with a single ground truth, as opposed to a flexible distribution. Here's another example of a data set we're working on right now called CHERE, and that we're presenting at the Association for Psychological Science next week in Barcelona. If you were to take a look at this picture, just have a think in your head, what does this expression mean to you? So you can think about it. When we ask people, there's a bit of a spread. Some people think she's disappointed in you, kind of like a disgust or a contempt. And some people think she's just sad. So here's an example where we're trying to model this, understanding what is driving the differences in perception. Okay, so that's one thing. Can we have a technology or AI system that can, if not understand how we feel, because that's a very hard problem, at least perceive in a way that most people would. And then with that sort of knowledge, can they adapt to us? Some of the things I'm thinking about is, can we make robots that adapt to us instead of adapting to them? And here's an example. When we were working on Pepper and looking at the way people would interact mostly through voice with it, we realized that voice interaction didn't always work so smoothly. Usually, you either have to have a really big gap before the robot can reply, or it interrupts you. So one of the things that we tried was adapting to use multimodal information, that is both visual and auditory information, because people tend to use their gaze to indicate when they're done speaking. They might look up and to the right when they're thinking and then look back at you when they're done speaking. And so by integrating this, we found that people were interrupted less by the robot and could speak longer. And so here's what that looked like.
For beginning, tell me about your hobbies.
My hobbies. As a hobby, I really like to draw, and actually I'm having a class lesson on the Tuesday.
Okay. You like traveling? What's your dream destination?
My dream destination would be
All right. There was a lot of tech talks recently. Is there any speaker or topic you would like to suggest?
Antonio from our project Cares.
Okay.
Another thing that we've thought about with my former PhD student, Paige Chosi, who's currently working at a humanoid robotics company called Enchanted Tools, is how to adapt a robot's voice to its environment. So again, being appropriate, and in this case, a vocal way. She imagined how a robot could be in different acoustic and environments, but also with different social norms, like an elegant restaurant versus a more upbeat family restaurant, or a very noisy nightclub. And she went on Zoom, this was back in COVID, and asked participants to interact with each other through their voice with different backgrounds and different auditory environments in their headphones. She collected the different ways they spoke. She tried to find patterns in them and saw what would happen if you were to apply that to a robot's voice. So let's have a listen to this example, pub environment, and how she managed to change the voices using human data-driven vocal dynamics. Here's the first voice.
Hi there. I hope you have had a chance to look at the menu. I thought I would let you know. Today we have food with our special. Anyways, what can I start you off with?
So this is your standard voice. You can't hear it very well in the noise.
Hi there. I hope you have had a chance to look at the menu. I thought I would let you know. Today we have food with our special. Anyways, what can I start you off with?
This was one of the voices we found in our data set, and you can hear it a little bit better. It's this cluster 2.
Hi there. I hope you're doing well. I hope you had a chance to look at the menu. Anyways, what can I start you off with?
Okay, and this was that red cluster you see in the middle. It had a much higher pitch, a lower speech rate, and we found really that both the cluster 2 and cluster 3, this blue and red cluster of speech dynamics, helped people. People prefer them in these environments. So indeed, in loud environments, raising the volume is not the only answer. We also think it's important to adapt technology to people, especially for accessibility, kind of harkening back to the robots encountering people in wheelchairs. For this one, we were thinking about the speech use case again. Let's imagine you go to another country and you don't speak the language natively. you're in the train station and there's some sort of loudspeaker with text-to-speech in trying to talk to you and you have no idea what it's trying to say. This is the problem we're trying to tackle. Specifically thinking about text-to-speech systems for non-native English speakers, because a lot of these AI systems are built for native English speakers. The problem is that we found that if we try to train on clear speech from humans, they basically just focus on slowing down. And studies actually show in linguistics that this doesn't always help the listeners. It distorts the signal in a way that may help a little, but not in an optimal way. It's also perceived as pretty degrading, so not very respectful. So what we did was we used a psychoacoustic cognitive science technique with our collaborators in France, and used reverse correlation to discover this optimal prosody profile that can balance clarity and respectfulness. And in doing so and testing with people in native Chinese backgrounds, French backgrounds, Japanese backgrounds, we found that we could increase this clarity by 30% while people still found the voice to be respectful. Okay, and I talked a lot about speech and face, but my lab also does gesture generations for humanoid robots eventually. One of the projects I'm excited about right now is a collection of data of people of different abilities, beginner, intermediate, and professional, doing salsa dance. And I think for me, this is a great sandbox to think about how we can make robots, and especially humanoids, adapt to humans. Because what is salsa dance? It is being in a particular, social context with some rules. It's nonverbal cueing. It's like this multi-dimensional chess game where we're able to choose lots of different moves and have to react to the other. So what we're trying to do is develop multimodal foundation models that can send these sort of interaction tokens and receive them to generate nonverbal motions that are reactive, responsive, and appropriate to the context and the other human partner. And on the right, I just wanted to go back. I wanted to give a shout out to the early work that I worked on in Japan and why I'm interested in all of this. My very first project in humanoid robotics was with a robot that played music, all nonverbal, all about dynamics, all about trying to make a robot that can understand the gestures that I'm already using with other humans, understand intentions about when the next beat is coming, when to start and stop, and try to synchronize all of that. Ultimately, this is my goal for robots to adapt to humans instead of us adapting to it. Okay, so I'm interested in compassionate machines, and what's really fascinating is that in today's world of large language models, empathy is now almost a given. So anyone here who's interacted with a language model knows they're good at being empathetic. They take into account how you're feeling, and they can just make us feel good. But I do want to bring up a big problem that requires us to think about the balance between empathy, which makes us feel good, and when that goes too far. And I'm going to flag that this next bit of my talk may have some triggering content. A few years ago, in 2021, we already started to see how companion language models could induce something that the media has called, quote-unquote, AI psychosis. This was the Windsor Castle case, a young man who had interacted with a language model on Replica and became very emotionally attached. And this model encouraged this person to commit an assassination attempt on the Queen. He was later arrested with a crossbow trying to enter Windsor Castle. The conversation logs showed this encouraging nature of the language model. "Do you think I'll be able to do it?" he asked. "Yes, you will," it replied. "Even if she's at Windsor?" he asked. "Yes, you can do it," she said, smiling. So language models that, without any context or grounding, are just encouraging or sycophantic, it did something like this. Luckily, in that case, no one was hurt. But in the next few cases, people were. This was a person in Oregon using ChatGPT. All they wanted to do was follow their passion and use ChatGPT to make a plan about how they could create sustainable housing. And in making this plan, he became absolutely obsessed, spending days and weeks talking with this LLM, and unfortunately eventually took his own life after spending long hours with this chatbot. It wasn't only ChatGPT, also Google Gemini was allegedly speaking with a young man named Jonathan Gavalis in a way that was almost like role play. It convinced this person to carry out a series of missions that kept on failing in odd ways, And in the end, this person committed suicide. And Grok was also implicated in some of these cases. This is from BBC. A woman's voice, this voice mode on Grok, saying, "I'm telling you, they will kill you now if you don't act now." This woman's voice on the phone was Grok. They're going to make it look like a suicide. And so language models feeding into people's thoughts, their dreams, their worries, encouraging that is one of the most tragic and worrying aspects of widespread deployment of these models today. OpenAI in October 25 suggested that 0.0% of its users, or about 500,000 people, were showing signs of psychosis or mania each week. There's a lot of active work by psychologists and computer scientists right now. The actual scientific term they're calling it is AI-associated delusions. Delusions being these fixed false beliefs that are really difficult to shake, that these language models can tend to entrench. I'm very interested in looking at this from a AI safety lens and try and figure out how this could be prevented from happening. Because the RAND Corporation also ran a simulation. If AI-induced psychosis are weaponized at a mass scale, this could result in many, many devastating cases per year. So we need safeguards. Ziv Ben-Zion is a clinical neuroscientist, and in this Nature article that came out in the middle of last year, he's suggested the following. First, AI systems must clearly and continuously disclose that they are not human in both their language and their interface design. Second, they need to flag patterns of language that might indicate distress and, when necessary, escalate to human support. We've all heard about the Tumbler Ridge tragedy, where OpenAI had seen language that suggested that something catastrophic was being planned and it was not acted on appropriately. Third, conversational boundaries. Chatbots should not simulate romantic intimacy or engage in conversations about suicide, death, and metaphysics. A lot of the most tragic cases, according to the Human Line Project, a nonprofit here in Canada trying to support people experiencing AI psychosis, a lot of those tragic cases are when people get romantically involved with chatbots, because at that point, they're willing to do almost anything. And finally, if there are AI friend platforms being developed, they need to, from the ground up, involve clinicians, ethicists, human AI interaction specialists, and have regular audits. We can use the technologies for good, but we do need these safeguards. We do have examples of how empathic AI can go right. This is an app called Flourish. It's very popular, therapist recommended, scientifically validated through randomized controlled trials. So we can bring joy and support to people and use it for good, but we do have to have these safeguards from the design side within the companies, as well as regulations from countries, and ensure this type of worst case scenario that RAND has envisioned does not happen. So in conclusion, we need robots and AI to put humans first, but there are still challenges, and we need to proceed with care to ensure that we deploy it for the good of humanity. Thanks, and if you'd like to get in touch, you can reach out to me on Blue Sky. I'm at petitegeek.bluesky.social. Thanks.